This video is about reading and initial exploration of a CSV file. So the video gives a worked example of reading data from a CSV file to perform some initial exploration of the data in order to get the data imported correctly and to perform some processing to eliminate useless attributes, as well as to start to think about missing data. So we'll cover the following topics. We'll use the read CSV operator and we'll let the import wizard take the strain. We'll look at some points of note that in my experience is worth just thinking about. So for example, duplicate attribute names, quite a neat feature of the wizard actually. Also take care to import correct attribute types. Once we've done the initial import, we can visualize it to see if we can see any obvious problems, and this will lead us on to handling missing values and ultimately eliminating useless attributes. So I have a process. It's very simple. It reads a CSV file. These commented out operators are to help me. I'm just going to put these in later. I've practiced. So the read CSV, it's going to read a large CSV file which is somewhere on my disk. I've already filled the name in. I'm going to run the import configuration wizard. And we see that the import wizard does a good job of quickly reading in everything, and you can see there are a lot of columns, a lot of attributes in this data, 110 or so I think from memory. And you can see when you do the initial import, you actually get to see the data as it appears in the CSV file. So you can see already that there's a column. The first row is the names of the attributes, and then the subsequent rows are the data. You can see also that it's semicolon separated. If I put comma in here, it won't work, so I have to put that to semicolon and let it refresh. You'll notice also that use quotes, it's defaulted that to true. If I turn that off, you can see the data is quite nicely structured. It's got quotes around it, so if there is an embedded semicolon in any of the data, that will still work. But anyway, let's turn that back on. So some initial observations of this data. I'm seeing numbers here, text here. That looks a bit like a flag, or it's probably a number. Oh look, latitude and longitude. There's some numbers here. These columns are in general called metric underscore date and time. Scrolling over to the right, more numbers. Oh, and here's some flags, available, unavailable, whatever that means. And right at the end there's something called type. Looks like a number. So we do next. So we're happy with the name as the first row. Now this is the important bit. This is the meat of it. So first thing to see is there are duplicate column names. So it's a nice feature of the operator, the wizard rather. So if I select that to status 3, that's better. Now it's had a go at guessing, and in my experience the ones to look out for are binominals. Sometimes if it sees a binominal, it guesses that as in the first 100 it's set to preview. You can sometimes get that wrong, obviously, if the 101st is not a binominal, but we'll leave it as is. And basically it's guessed. Well, these look like good guesses. Yep, you can see there's a binominal, and keep going, keep going, keep going, keep going. Yep, the last one's there, an integer. So I'm going to take these guesses as a good first guess. Let's just accept all of those and run the process. It's quite a big file, takes a few seconds. So it's imported it. There are 22,218 examples, 114 regular attributes. I can see that ID, that probably should be changed to be a role ID. Let's click on the statistics view. So yep, sure enough, if I select here only those attributes with missing values, we can actually start to get to the nitty-gritty of what's maybe gone wrong on the import. So there are 2 attributes that have missing values associated with them. In my experience, it's worth just re-examining the wizard settings to see if you can eliminate those. So if we go back to the data, what I'm going to do is find those attributes. There's one. So what you can do is, if you do move column to position 2, and then if I go over to the right, yeah, here's type, let's move that to, oops, column position 3. So all I've done is reorder these. So now metric, run and type are shown early on, so we can actually see them in one place, and you can see there's a missing value now, and there's no missing value yet for type. If I scroll down, you can see the occasional missing value in the metric run attribute. Not that many, but nothing so far in the type. Now the type attribute, so experience teaches you this, but this is probably because of an import problem in the wizard. If I keep going, eventually, oops, there we go. There we can see a block of missing values. Now, experience teaches you this, but it's very late in the file, so the wizard has not seen it during its guessing process. So basically what I think has happened is the type has been guessed to integer, but in fact it's a nominal. So what I'm going to do is go to the metadata button here, and I'm going to go all the way down to type. So type is, it's defaulted to integer, but I think that's wrong. I'm going to set that to polynomial and apply that. If I run that again now, we should see a better result, fewer missing values anyway, because the type column should now import correctly. So statistics view, show missing ones only. Now only the attribute metric run has missing values. We go actually to look at the type column. You see it's now imported as a polynomial. The fact that we're leading zeros makes me think, yes, this is definitely right. And if I scroll down, oh, there was one flashed in front of our eyes. The best way to do it, actually, let me go back to the view here. If I find the type column, here it is, it's polynomial details. You can see some of the allowed values have no letters in them, so these are genuine text values. So I was right. So a lot of them appeared to be numbers. So 006 was the most common, but it isn't really a number. So that's chalked that one down to experience, but basically we've now eliminated some missing data, which is a good thing. The other missing data looks to be much more random. So one approach is simply to replace the missing value, which is the attribute called metric run, with an average. So if we run that again, now this, just doing this is without thinking about the source of the missing data is an error. You should in practice always have a really good think about why it's missing, because there can be all sorts of different ways data can be missing, and by introducing an average like I've done, it may be skewing the data in a way that means that any model I make later is not worth the paper it's virtually printed on. So now look, here we go, metric run, no missing values, and I would need to do a much more sophisticated analysis to really work out actually has that made a difference. But I'm leaving it here for now just to illustrate the point that what you can do. So now let's inspect the data to see if we can see any outliers. Now you would perhaps at this point run one of the outlier detection operators. I won't, because the data is too big. I don't have enough memory in this version of RapidMiner. I'm not licensed. So I'm going to use my eyes to look for data. So if I go back to the results view, and if I use the advanced charts view, and lat and lon were interesting, so I'm going to plot longitude and latitude. Now, those familiar with the United Kingdom will see a map of the United Kingdom, and this is essentially what all these data points are. But there are two rogue data points here. They're in France. Lucky them. So very clearly there's something wrong with these 2 points. Now the only thing I can do is to filter them out. I'm going to apply a simple rule. I'm going to say if latitude is less than this is the most southerly point you can get in Britain on the Channel Islands, then I'm going to say remove it, and I'm removing it by doing this invert filter here. So if I run this again, now if I plot it, the 2 data points that were in the wrong place have been just deleted, and we get data that looks a lot nicer. And now we can start to think about playing around with the size of these data points perhaps, and the colours of them, and we can start really doing some nice exploratory data analysis to see if these numbers mean something for the particular business problem. Now, it doesn't really matter what the problem is in this case, but you can start fiddling around this, doing visual inspection to get a sense as to whether the numbers are right. And one thing you can do is, if you go to the charts view, if you use histogram, for example, if you've got numbers, you can do this sort of exploration, perhaps put a log scale on, and what you might do is you might do a manual inspection if you had the time, and you can just look to see if the shape of this histogram is the same. So the sort of implication is that all of these metrics are derived from a similar source. There's no obvious wrong ones. But there isn't time to do it now, but that's the sort of thing you might start to embark on. And then the final thing I'm going to do is I'm going to do this remove useless attributes. This is always worth doing. I'm going to set this to this nominal useless below to 0 for now. And here's the result. I pressed pause. What this has, let me run that again, this time with the original data set. So we compare and cross. So if I run it again now, I'll remove useless below in this nominal useless below, so that to 0 for now. Just take the defaults of remove useless attributes. Run it again. Okay, so now the original data had 114 regular attributes. The data after the removal of useless has removed status 2, whatever that is, and that's simply because it's the same value. If I go to the statistics view here, status 2 has no deviation, so they're all the same, all of these values, and therefore you can safely remove that because it can have no effect on any label you might be trying to predict. But you can also, if you're feeling strong, I suppose, you can decide to remove nominals, where if I set this to 0.1 it means 10%, think of that as 10%. So if the number of, if there's the maximum nominal, the maximum occurring nominal occurs in fewer than 10% of the cases, then it's likely that it's not going to be predictive of the final outcome. So I'll run that again. Let's just see if there are any nominal attributes like that. Hint, I happen to know there is one, but we'll compare the before and after. So again, there were 114 at the beginning, but afterwards now status 3 has been removed. You can see it here. So status 3 has been removed because there are so many different values of status 3. It's not likely to be predictive of any label you might want. You can see this also, status 3. There are literally hundreds, thousands in fact, of nominal values, and so it's unlikely that they're going to have any effect. So that's quite a nice. So remove useless is quite nice to quickly get rid of things that are of 0 value. Okay, so now we've got to the point where our data is in reasonable state and we can start doing more things with it. What I'll leave you with is the map of the UK with the nice colours, because it looks nice. There we are, and advanced chart. That long. Let's pick some random one, colour that. How nice.